All right, greetings. Welcome to Eureka Math Squared. This is grade 6, lesson 3, all about finding the greatest common factor, also known as the GCF. Now, in lesson 1, I went through this a bit. So in this particular video, I'm going to concentrate on what is called prime factorization, one of my favorite things in the whole world. Factorization, and I hope I spelled that correctly. And in order for you to be successful with prime factorization, you need to know what a prime number is. Okay, so prime numbers. Now, prime numbers simply mean, two numbers, a number that have two factors. Okay, two factors, one and itself. Here's what I mean by that. The number 13. Okay, it only has two factors, right? So a 13, there are only two numbers that you can multiply to get 13. There's a 1 and there's a 13. And there you go. And that's a prime number. So the number 7, that would be prime because it has two factors, 1 and 7. Okay, the number 9 is not a prime number because other than 1 times a 9, right, you also have a 3 times a 3. Okay, so we call those numbers composite numbers. Okay, and not prime, right? So these are composite numbers, all right, and not prime numbers. So we're going to concentrate on prime numbers, okay? All right, so we're going to hang out on page 33, and we're going to put our prime factorization in motion. Okay, so we're going to find the greatest common factor of these two numbers. Now, normally I might tell you, hey, list these guys out and start talking about how many factors they have, right? So 1 times 36, a 2 times an 18 kind of thing, and you're cruising through all these guys, right? So 3 times something, and then there's a 1 over here and a 48 here, and you need to get all these guys. Now, if you miss one of the factors, then you're out of luck. Kind of a pain in the neck. Or you can do the chart method, which I'm a big fan of too. And you put a bunch of rows and columns and you say, hey, 1 times 36 gives me 36. And a 2 times 18 gives me 36. And a 3 times 12. And you keep on going. And hopefully, again, you have all the factors by the time you're done. So you can get that GCF. That's a lot of work, right? So listing all these factors, making charts. Good grief. I'm going to show you prime factorization. And prime factorization goes a little bit faster once you get used to it. Okay, so what you're going to do is take the two numbers and you're going to list them out like this. You're going to put a 36 on the left side, perhaps, and the 48 on the right side. And all you're going to do is list out two factors, any factors you want, other than 1 times 36. You're going to avoid the 1 because it's really not going to be helpful here at all. Okay, so let's say we have how about 6 times 6? 6 times 6. So any two factors that give you the 36, right? So 6 times 6 gives me 36. Now what's going to happen is we're going to continue to break these numbers down until we get prime numbers. As soon as we get a prime number, we're going to circle it. Okay, so 6 times 6, other than 1 times 6, I'm going to use a 2 times 3. Now 2 is a prime number because it only has two factors, 1 in itself, right? And 3 is a prime number. 1 times 3 are the only two numbers you can use to get a product of 3. So I circle those because those are prime numbers. Now for the other 6, the same thing is going to happen, right? I'm going to get a 2 over here and a 3 over here. I'm going to circle those. Now if you decided not to use, watch what happens here. If you decided to use two other numbers, let's say you wanted 2 times 18, right? Because those give you 36. Or perhaps a 9 times a 4, right? Because those two numbers give you 36. That's fine. Watch what happens here. The 9 becomes a 3 times 3, right? Circle those because those are prime. And the 4 becomes a 2 times 2, right? Because 2 times 2 gives you 4. And you would circle those. Now, guess what? Earlier, when we were done, we had 2 2s and 2 3s. Well, guess what? We got them again, right? So if you decided to use, what was the other one we didn't use there, right? A 2 times 18, I believe, right? A 2 times 18, 2 is prime, so that gets circled right away. And I say, hey, how do you get 18? How about a 2 times 9, right? 2 gets circled. Once it gets circled, you're done. You don't break it up anymore. And 9 gets broken up into a 3 times 3. Guess what? There are those two 2s and there are those two 3s, all prime numbers. Cool, right? So if you actually multiplied all these guys together, guess what? You get that 36. Okay, so any number is a product of its prime numbers. So let's go over to the 48, okay, and do the same type of thing. Okay, so I need two numbers that when you multiply, you get 48. How about a 6 times 8? They give me 48. I'm going to break the 6 up since it's not prime, not yet, right? So a 2 times a 3, that gives me 6, so I circle those. Over here, I get a 2 times a 4, right? 2 gets circled because it's prime, and the 4 gets broken up into 2 sets of 2. 2 times 2 gives me 4, so those all get circled. Okay, so after a while, when you get practiced in this, it goes very fast. Now, what do you do? Now, watch this. Here comes the fun part. So I'm going to write the GCF. Now, here's how it works. Now, pay attention. Every time I have a match for both, so I have a circled number that's a match for both, I'm going to list it down, list it under the GCF area. Watch this. So I have a 2 on this side and a 2 on that side. So I'm going to cross those off, and I'm just going to list 1, 2 right there. Okay, now I'm going to look for another match. This side has a 2, and this side has a 2. Okay, if they have a match, I list it using multiplication. Now, there are no more 2s over on the left side. There are a couple of 2s on the right side, but there are no matches on both sides, so I'm going to leave those. Okay, so those guys are out of the game. But I do see a 3 here and a 3 there. Again, they have to be on both sides. If so, I list that 3 in my little GFC area. Okay, now I am left with a 3 over here, but there are no 3s on the other side, so I have to leave that. I have a 2 over here, but there are no 2s left over here, so I leave that. There's another 2 over here, but again, no 2s over here, so I leave that. So now I'm ready to rock and roll. All I have to do is take these guys and, multiply, and I get 12. There it is. So guess what? My GCF equals 12. And that's how it works. Okay, so instead of listing all kinds of factors, I can use this prime factorization method, and it goes very fast once you get used to it. Okay, so let's play again. So here's 36, right? And here's my 55. I'm going to do the little GCF of those two using prime factorization. Okay, so let me do that 6 times 6 from before. Right, 6 times 6, I don't circle those because they're not prime yet. But a 2 times 3 gives me both two prime numbers. And another 2 times 3 gives me prime numbers. So just like that, that's ready to go. So instead of listing every factor of 36, I just broke it down into prime factors. Now this one here, this one's even faster. Watch. 5 times 11. Oh, excuse me, not 10, 11. 5 times 11. Now guess what? 5 times 11, 5 is prime, but so is 11. Those are done. Just like that. So I'm going to do my little GCF. Now I'm going to see if I have a match. 2 here, but no 2 over there. 3, no 3. No 2s, no 3s. There's a 5 here, no 5 over here. 11, nothing. There's nothing that matches. If nothing matches, your GCF is 1. That's it. And we're done. Okay? So let's put this into practice here. So Riley has 28 pens and 14 notebooks. What is a GCF of those guys, right? So she wants to take all of the pens and notepads and make gift bags, right? So every gift bag needs the same amount of pens and notepads. We want to find out the maximum amount of gift bags she can make so that every gift bag has the identical materials in it, right? Pens and notepads. So I want the GCF. So I'm going to use prime factorization. Let's see. I'm going to list my 28. I'm going to break that up into, how about 2 times 14? Okay, that gives me 28. I'm going to circle that too. That's prime. Well, 14, I can break that up into a 2 times a 7. Both of those numbers are prime, so I circle those. So 28's done. Let me cruise over and use the 14. Well, there are only 2 other things I can do here for 14, right? A 2 times a 7. Only 2 factors I can use here in my prime factorization, and I'm ready to go. So watch this. GCF. I have a 2 over here, I have a 2 over there. I like to cross them out so I can see what I did. Now I don't have a 2. Oops, I shouldn't have crossed out that 2, right? Because let's see, let's circle him. There's no 2 on the other side, right? So that doesn't work out. But I do have 2 7s. A 7 on each side, I mean. So I'm going to list that. All I have to do, multiply those numbers that the prime numbers both values share. Multiply those together and I get my 14. So they can make 14 gift bags. All right, so 14 gift bags can be made. All right, so 14 gift bags. Now, how many pens? And how many notepads per, right? Well, if I have 14 gift bags and 28 pens, right? So here's my little pen side, right? Pens and notepads, right? So I'm going to take my maximum number of pens, and if I have 14 gift bags, that means I'm going to have 2 pens each, right? So 2 pens each in each bag. And notepads, well, she only has 14 notepads, and she's making 14 gift bags. That means only 1 notepad, right, per gift bag, right, sir? Per gift bag. Just like that. Okay, so each gift bag has 3 items, 2 pens and 1 notebook. 14 total gift bags, GCF 14, all right, out of 28 total pens and 14 total notepads. Okay, as we scroll down on page 34, then it gets, it tries to mess you up a little bit with this prime factorization stuff. Here's what they want. The 36, and I think we sort of did this already. They want all these fun little combinations of 36, right? So 6 times 6 and a 2 times 18, right? And a 9 times, what was that before, right? A 9 times 4, and what am I missing here? A 3 times 12, I believe. And they're just proving what I already said before. Give me all the prime factorizations. Well, this 6 over here is a 2 times a 3. This 6 is also a 2 times a 3. And what you're going to notice is you're going to have the same prime factors by the time you're done, right? There's the 2, and the 18 is a 2 times 9, right? There's a 2, but the 9 is broken into 2 3s, right? So there they are. This 9 is 3 times 3. Those are prime numbers. This 4 is a 2 times 2. Again, you'll notice everything has 2 2s and 2 3s, 2 2s and 2 3s, 2 2s and 2 3s. There's that 3, and this 12 is broken up into 2 times 6, but the 6 is then broken up into 2 times 3. All right, so those all match. And that's what they're doing with that. Okay, and then they say, hey, do that with the 48. It's the same type of thing, but let's just do one more for fun. Okay, so 26, and you don't even need a lot of space. Watch. 26, I'm going to break those up. Let's see, so that's a 2 times that's a prime times a 13, and 13 is prime also, so that's done. Okay, how about let's see, how about a 3 times a 13, right? All right, that gives me 39, and so they only share a 13, right? So GCF is the 13 because that's the only thing they share. Just like that. So instead of listing every factor and then trying to find the ones they have in common, and if you miss one, it's a big pain in the neck, just do the prime factorization and you're in great shape. Okay, so that's the deal. I hope you enjoyed that. All right, have a good one. Take care. Bye-bye.